Welcome back to the Architecture Lab. Today, we are expanding our generative AI horizons by chaining calls with open source orchestrators, focusing heavily on LangChain and Amazon Bedrock. Welcome, architects, to an exploration of advanced programmatic access. Today, we are focusing on chaining calls with open source orchestrators. Up until this point, we have primarily discussed invoking foundation models in isolation. You send a prompt, and you receive a response. While this is fantastic for simple tasks, enterprise-grade generative AI applications are rarely that simple. What if you need to fetch data from an SQL database, summarize that data with an LLM, translate the summary into Spanish, and then send it via email? Managing that complex, multi-step sequence manually using raw Boto3 API calls leads to fragile, tightly coupled, and bloated application code. To solve this, we introduce the orchestration paradigm. We utilize frameworks designed specifically to manage the complex flow of data between language models, external data sources, memory modules, and utility functions. Amazed! Open source orchestrators, with LangChain being the absolute pioneer and industry standard, abstract away the low-level API complexities. LangChain allows you to build modular chains, where the output of one component automatically becomes the input for the next. This enables you to string together multiple Amazon Bedrock models and external tools to create highly sophisticated autonomous AI pipelines. By bridging Bedrock's scalable infrastructure with LangChain's flexible orchestration, we achieve the ultimate balance of power and agility in application development. This flowchart illustrates the paradigm shift. Relying solely on raw API calls results in bloated, fragile code bases. Adopting LangChain orchestration unlocks modular, reusable components, allowing you to seamlessly chain data fetching, Bedrock LLM processing, and final action execution. To begin orchestrating, we must first understand how LangChain physically integrates with Amazon Bedrock. LangChain provides purpose-built wrapper classes that cleanly encapsulate the underlying AWS Boto3 SDK operations. Instead of manually formatting JSON payload bodies with exact MIME types and provider-specific configurations, LangChain provides a unified interface. How do we establish this connection in Python? We import the Bedrock LLM class, or traditionally the Bedrock class, directly from the LangChain AWS or LangChain community integration libraries. When instantiating this class, we simply pass our pre-configured Boto3 Bedrock runtime client, specify the precise model ID we wish to invoke, and provide a dictionary of model carwargs. This model carwargs dictionary holds all of our critical inference parameters, such as temperature, top P, and max tokens. By doing this, we create a highly portable LangChain LLM object. This object can now be seamlessly plugged into any downstream LangChain pipeline, agent, or memory module. It serves as the cognitive engine for our entire open source orchestration setup, backed securely by Amazon's cloud infrastructure. Let's analyze this robust integration code. First, we instantiate our standard Boto3 Bedrock runtime client securely. Next, we import the Bedrock LLM class from the LangChain AWS library. We create our LLM object by passing the Boto3 client, the Amazon.Titan TG1.large model identifier, and a highly structured dictionary of model carwargs containing our exact inference parameters. We have now completely abstracted the Bedrock API. To generate text, we no longer build complex JSON payloads, we simply call llm.invoke with a raw string prompt. LangChain securely serializes the request, transmits it to AWS, and returns the generated text seamlessly. It is an incredibly clean developer experience. This diagram maps the abstraction process. The Boto3 runtime client and our model ID and carwargs are injected into the Bedrock LLM wrapper class. This yields a portable LangChain LLM object. When we call invoke, it triggers abstracted API execution, securely returning the generated string response.
Having instantiated our LLM, we must now address how we feed it instructions. In a production environment, dynamically constructing prompts using raw Python string concatenation is highly error-prone and severely limits reusability. How does LangChain solve this? With the incredible prompt template class. A prompt template is a predefined structured string format that acts as a blueprint for your AI interactions. It allows you to write the core instructions in context once and then define dynamic placeholders using curly braces. For example, if you are building an email generator for customer support, you define placeholders for leasing agent, tenant name, and feedback from tenant. You explicitly declare these as input variables when creating the template object. This establishes a strict data contract. If a downstream system tries to use the template but forgets to provide the tenant's name, LangChain will instantly throw a validation error, preventing a malformed prompt from ever hitting the Amazon Bedrock API. When you are ready to generate, you simply call the template's .format method, passing in the live application data. This process seamlessly replaces the placeholders, returning a perfectly structured, context-rich prompt string ready for inference. Prompt templates are the foundational building blocks of reliable orchestration. Observe the elegance of the prompt template. We instantiate the object and explicitly declare our input variables array, agent name, customer name, and issue. The template string contains the static instructions, heavily utilizing curly braces to mark the exact injection points for our dynamic variables. We even use XML tags around the issue to enforce structure. During application runtime, we execute the .format method, supplying our live data via keyword arguments. LangChain performs strict validation, ensuring all variables are present and seamlessly injects the data. The resulting formatted prompt is a pristine, robust string, perfectly optimized to guide our Bedrock Foundation model without any chaotic manual string concatenation.
Now for the magic, chaining the components together. We have an initialized Bedrock LLM object, and we have a dynamic prompt template object. How do we make them communicate seamlessly? We bind them into a chain. In LangChain, a chain is an orchestrated sequence of calls. Historically, we used the LLM chain class for this, passing the prompt and the LLM as arguments. However, the modern standard is utilizing LangChain Expression Language, or LCEL. LCEL provides a highly intuitive, declarative syntax using the pipe operator. You simply write chain equals prompt/LLM. This single line of code creates a powerful pipeline. When you invoke this chain with a dictionary of input variables, the system automatically routes the variables into the prompt template, formats the string, pipes that exact string directly into the Amazon Bedrock LLM, and returns the final generated output. It completely automates the handoff between data formatting and model execution. This modularity is why orchestration is so powerful. If you decide to swap your Amazon Titan model for an Anthropic Claude model tomorrow, you only update the LLM initialization. The rest of the chain, the prompts, and the data flow remain completely untouched. Let's break down this beautifully chained workflow. We complete step 1 by initializing our Bedrock LLM wrapper, targeting the Titan model. In step 2, we construct a simple prompt template demanding an explanation of a dynamic topic. Step 3 is the masterstroke. Using LCEL syntax, we declare chain equals prompt template/LLM. This explicitly binds the template's output directly to the LLM's input. Finally, in step 4, we call chain.invoke, passing a dictionary with the topic quantum computing. LangChain autonomously formats the prompt, transmits it to the AWS cloud, waits for the Titan model's inference, and prints the perfectly crafted paragraph. We achieved end-to-end orchestration in less than 10 lines of Python. Simple prompt chaining is useful, but enterprise value is unlocked when we orchestrate Retrieval-Augmented Generation, or RAG. RAG allows our models to answer questions based on proprietary corporate data. LangChain provides the ultimate ecosystem to orchestrate every single phase of a RAG pipeline. What components are involved in this advanced chain? First, LangChain offers document loaders to seamlessly ingest PDFs, CSVs, or text files from your local storage or Amazon S3. Next, text splitters algorithmically chunk these massive documents into smaller, semantically coherent segments, preventing us from exceeding the LLM's context window. Then, the orchestration truly shines. We utilize an embedding model, such as Amazon Titan text embeddings via Bedrock, to convert these text chunks into high-dimensional vectors. We pipe these vectors directly into a vector store, such as Face, Chroma, or Amazon OpenSearch Serverless Library. When a user asks a question, LangChain autonomously embeds the query, executes a similarity search against the vector store to fetch the most relevant document chunks, injects those chunks into a predefined prompt template as context, and routes the final massive prompt to the Bedrock LLM to generate a perfectly grounded answer. LangChain connects all 5 of these disparate systems, loaders, splitters, embedders, databases, and LLMs, into a single unified executable Python chain. This is the comprehensive RAG orchestration flow. Document loaders feed text splitters, generating chunks converted by the Bedrock embedding model into a vector store. A user query triggers a similarity search, constructing an augmented prompt that drives the final Bedrock LLM generation.
We must now elevate our orchestration to the highest level of cognitive autonomy, LangChain agents. Unlike static chains, where the sequence of operations is hard-coded by the developer, an agent uses the LLM as a reasoning engine to dynamically determine which actions to take and in what order. How does this work? It relies heavily on the React framework, synergizing reasoning and acting. In LangChain, you initialize an agent by providing it with a Bedrock LLM and a toolkit. A toolkit is an array of functions the agent is permitted to execute, such as searching Wikipedia, scraping YouTube, executing Python code, or querying an SQL database. When a user submits a complex prompt, the agent enters a loop. It thinks, to answer this, I must search Wikipedia. It executes the Wikipedia tool, observes the extracted text, and thinks again. Now I have the facts. I can formulate the final answer. The agent orchestrates its own data retrieval iteratively until it solves the puzzle. By binding the raw reasoning power of models like Anthropic Claude on Amazon Bedrock with the diverse tool integration of LangChain, you construct digital workers capable of profound, multi-step problem solving. Observe the autonomous agent loop. The LangChain agent uses LLM reasoning. If an action is required, it executes a tool from its toolkit, observes the output, and loops back to reasoning. Once the task is solved, it proceeds to final answer synthesis.
As we conclude our orchestration deep dive, we must discuss production deployment. Running LangChain scripts on a local laptop is fine for testing, but enterprise applications demand robust, scalable infrastructure. We must adhere to the AWS well-architected framework, prioritizing security, performance efficiency, and cost optimization. To deploy these LangChain workflows effectively, we utilize a serverless architecture. We package our Python code, including the LangChain library and our specific Bedrock integration logic, and deploy it inside an AWS Lambda function. Why Lambda? Because Lambda automatically scales in response to incoming traffic, ensuring that whether you have 1 user or 1,000 users simultaneously requesting AI generations, the compute capacity dynamically adjusts without you provisioning a single server. Amazed, we then place an Amazon API gateway in front of this Lambda function. This acts as a centralized, secure entry point for our web or mobile frontends to trigger the orchestrated chain. API Gateway handles throttling, authentication via Amazon Cognito, and request routing. This architecture, API Gateway to Lambda to Amazon Bedrock, creates a highly resilient, globally scalable generative AI backend. I hope this orchestration masterclass empowers you to build sophisticated AI pipelines. We invite you to like, subscribe, and visit quicktechie.com for premium and for recently updated material as per latest syllabus and certification prep, including Q&A banks, ebooks, audiobooks, full training, and interview guides. This is the ultimate serverless production architecture. The front-end app communicates via REST to the API gateway, which securely triggers AWS Lambda containing our LangChain orchestrations. Lambda then invokes the highly scalable Amazon Bedrock models, returning the results seamlessly to the user.